Okay, just wanted to wrap up a couple of things that I said on the last video and get them added to your notes so that you'll have them to refer back to. I'm pretty sure one of the questions that you're going to have to answer is when you have the parent function, can you identify the values of a, h, and k? So the parameters a, h, and k are in every absolute value function. You just have to be able to recognize when we don't see a number in front of this absolute value bar, we know it's an understood 1. So this one right here, I didn't mean to make that mark, can be rewritten with a 1 right there. If we don't have a minus h, we understand that that's the same thing as saying minus 0. And if we don't have a number added at the end, we understand that's the same thing as saying plus 0. So when we have our parent function, we do have values of a, h, and k. It's just that you have to understand that we don't see a number, so we understand it's being multiplied by 1. So the absolute value parent function has an a value of 1, an h value of 0, and a k value of 0. So that was something that I just wanted to remind you, because I do believe you're going to be asked that question in one of your problems. The other thing that I wanted to have you add to your notes is when you have parameter changes, the vertex, which is this point right here, that either the lowest or the highest point, the vertex is always going to be located at HK. So whatever these two numbers are, even if they're zeros, you need to be able to identify where the vertex is. The domain for all absolute value functions will always be negative infinity to positive infinity. And then your range is going to be changed by two things. It's going to be changed by your k, and it's also going to be changed by whether or not your a is a positive number, which is going to have a graph opening up, or whether your a is a negative number. That means you're going to have a graph that's opening down. So if you have a positive graph and your graph is opening up, then that means that your k value, wherever it is going to be where your range starts. And then it's going to go off to positive infinity in both directions. So it's going to stop at positive infinity. It's going to start at k. It's going to stop at positive infinity. If your a value is negative and so this is the graph, looks like this. This is your absolute value graph. It's opening up. This means your absolute value graph is opening down. When your absolute value graph opens down, that means that your range is going to start at negative infinity, because it's going to be pointing, the two ends are going to be down here. It's going to start at negative infinity, and it's going to go up until it gets to the highest point, which is going to be your k value. It's always going to include k, because k is going to be the point on the vertex, at the vertex, so it is going to include it. As long as we have equalities, we are going to be looking at absolute value inequalities, and that may change the value of k, or whether or not we put, it won't change k, but it'll change whether or not we put a parentheses or a bracket. All right, so what kind of problems are you going to have to be able to work? You're going to need to be able to be given an equation, an absolute value equation, and describe the transformations that take place and also graph it. I think it's an excellent idea to always have a graph of the parent function. If not physically on your paper, then at least mentally in your mind, know that that's what the parent function looks like, and then identify each one of these values. This value is the h. Be very careful. The h is where everyone makes mistakes. I see right here a minus sign. Remember that minus sign is part of the formula. The formula is a absolute value x minus h plus k. When you see a minus, know it's part of the formula, so that means the value of h is 1. The value of k is negative 2. H is always the opposite of what you see. K is always exactly what you see. then it makes it a lot easier to describe the transformations. Of course, you can always go back to your note page right here, and we see that we have a positive h. Since we have a positive h, this is h right here. Since we have a positive h, we're going to go right 5. Shift right when h is positive. Okay, so that might be something when it looks like his. When h is positive. And you're going to shift left when h is negative. Okay, so here we have a positive h, so we're going to shift. Positive is right. We're going to shift right 1, and we're going to shift down 2. So let me do it in a new color. This vertex right here is going to be the easiest one to move. They all move the same direction, but I like to start with my vertex. You move it to the right 1, and then you move it down 2. There's the new vertex. I didn't dilate it. I didn't change its size. So from the new vertex, I'm just going to go over 1, up 1 in both directions, and do that several times, over 1, up 1, over 1, up 1, over 1, up 1, and then get me some dots, and then there's my transformed graph. Every dot, oh, I messed up somewhere right there. Over 1, up 1. Okay, so the transformed graph, not that one, I goofed up. Over 1, up 1. That's what we do, because we didn't have a dilation because we didn't have an a. This one, you have a is -1, h is +3, k is +3. So you're going to describe each one of these. Each one of these caused something to is -1. My goodness, I'm making mistakes. So since it's a -1, we have a vertical reflection. The A is what's giving us the vertical reflection, and it's going to be a vertical reflection over the x-axis. And then the H is making us shift. It's a +3, so it's going to go right 3. And the K is making this shift. It's a +3, so it's making it shift up 3. Okay, so again, keep in mind where the parent function is. The reflection doesn't change the vertex, but it is going to change by the fact that it's going to make the branches go down instead of up. So I'm going to find the new vertex. I'm going to shift it to the right 3, and I'm going to shift it down 3. There's my new vertex, and this time I'm going to go over 1, down 1 in each direction, and just